Welcome to another lesson today, where we're going to apply Newton's laws of motion. But in particular, we'll look at the application of these laws to an inclined plane. And basically, we'll look at the types of friction forces which come to play for an object which is moving on an inclined plane. And so, in particular today, we'll just look at our emphasis will be based on looking at the friction for an object which is not moving, which is the static friction. And so here we go. So, what is friction? Friction actually is the opposing force or the resistance force that tries to impede the movement of the object. And so, normally, friction is directly proportional to the normal force, meaning that as the normal force increases, the friction force also increases. And therefore, friction is equal to mu. Mu here is the coefficient of friction multiplied by the normal force. And as we indicated the area for an object on an inclined plane, and this object is not moving up or down, it means that the normal force will be equal to mg cos theta. This is the angle here, theta, which is equal to this angle here. And if we draw a right angle triangle here, we find that this side here is adjacent to this angle, and therefore it represents the mg cos theta, where the hypotenuse here is the mg, which is the weight of the object. And so what we are saying here is that the normal force is equal to mg cos theta, which we have shown here. If that is only if this object is not moving up or down. And so the other side, which is opposite to this angle here, which is this side, which is represented by mg sin theta, is the same as this side. Since this is parallel, this is the same as this one. So today we'll look at an object which is resting on an inclined plane. And already here you can see that there are two forces which are acting on this object. One of them is this. If this object is to move downwards, it is mg sin theta. And there will be a resisting force, which is the friction here. Okay, which is this, the friction which was in between the object and the inclined plane. And the area, we said the friction is actually proportional to the normal force, direct proportion to the normal force. And therefore, we can note that the force of static friction for an object, if this object is not moving at all, because there is a small force which is making it to move. And therefore, you note that the static friction of this object would be the coefficient of static friction multiplied by mg times cos theta. That is for objects not in motion. For objects which are in motion, the kinetic friction, which is the force of kinetic friction, will be equal to coefficient of kinetic friction multiplied by mg cos theta. So the force of kinetic friction is only for objects which are in motion, and the force of static friction is only for objects which are static, they are not moving at all. And so, as I indicated here, I said mu ke here is the coefficient of kinetic friction. This is only only applied to objects which are in motion. And while mu s here, which is coefficient of static friction, it is the coefficient for objects which are static, they are not moving at all. And so this is the basic concept here which we have learned. First, the most important concept we have learned is that for an object which is not moving up or down, the normal force will be equal to mg cos theta. Okay. And so we want to apply now what we have learned so far to the scenario. We have a question here. A 4 kg book is resting on an inclined plane where the coefficient of static friction is 0.3. What maximum angle should the inclined plane make with the horizontal before the book starts to slip down? So we have a book here, which is resting here, and they want us to find the angle here, and they are saying for what is the maximum, there is some maximum force which will be applied so that this does not move. So in other words, what this implies is that mg sin theta will be equal to friction, though this object will not move. If mg sin theta is equal to the frictional force, it will remain stationary here. And therefore, what we apply here is the coefficient of static friction. And therefore, we are aware that the normal force is equal to mg cos theta from here, if the object is not moved up or down. So the normal force is equal to mg cos theta. And then the frictional force is equal to mu Fm. Okay? And we are aware that the frictional force is equal to mu mg cos theta, as we discussed earlier. And so, in our case, since we said this object is not moving, it is stationary here, it implies that the frictional force will be equal to mg sin theta. And that's what we have written here. And we know that this static friction is equal to mu static friction mg cos theta. And then we substitute where there is friction here, we substitute mu mg cos theta. And therefore, you can now and substitute what is the variable, and therefore we are aware that we have been given the coefficient of static friction, so we can make it the subject of the formula. To make this one the subject of the formula, you are going to have mg sin theta over mg cos theta. And we know that mg here and mg here, they will cancel out. And therefore, we are going to remain sin theta over cos theta. And from geometric identity, sin theta over cos theta is equal to tan theta. And therefore, since we know the value of the coefficient of static friction, we can now calculate this, which is 0.3. We can now calculate the angle. And the angle, therefore, is 16.7 degrees. So the other concept to note here is that we are aware that the coefficient of static friction does not depend on the mass. It merely depends on the angle. The thing that the angles, the masses here have cancelled out. And so this is how we can apply the coefficient of static friction. So next time we will look at another application of the concept which will help us to use the coefficient of static friction for an object which is in motion. It will be coefficient of kinetic friction which we are going to use here. So I hope you have enjoyed the lesson, and therefore you can subscribe to my YouTube and then you make sure that you attend the other upcoming lessons. Thank you.